Hello, everybody, and welcome to another episode of Fresh Thinking by Snowden, Optiro. This is a series of podcasts where we take ideas that may seem complicated, but we break them down in a way that's interesting and useful to you and your work in the mining industry. So today we're going to speak again about convolutional neural networks, or CNNs, nothing to do with cable news network or cable channels. We're going to talk about how these can be used to improve resource estimation, particularly resource estimation at the early stage of data when we have sparse data, and how we can actually use the relationship with complex and dense grade control data. So to talk to us about this, I'm joined by Dr. Greg Zhang, who is a geologist and also a data scientist. And Greg's been doing a lot of work on this at the moment. So Greg's going to explain to us exactly how it works.
Thank you, Ian, to have me. Great to be here.
Good. So let's start off with this issue we've got, where we have at a mine, an operating mine, we have a resource estimate, mineral resource estimate, and we also have a grade control model. So typically at a mine, the resource estimate is built on wide space drilling and some inference between the drill holes. Whereas at the same time, or at a later time, we've got dense grade control drilling, which is detailed drilling, and we also have accompanying that mapping and other information. So these obviously, Greg, one of the issues we've got is that these models don't always match, right?
Exactly. So the resource model is usually based on very sparse data, and it's designed for the long-term planning. So answer the questions like, do we have an economic ore body, and what's the approximate tonnage and grade over the life of mine? And once we start to mine, we would collect grade control data, and then either it's blast holes or infill drilling with RC holes. Then those are all with much tighter spacing, and then that's where we would discover that the local grade variability that doesn't. Let me do that again. So that's where we find that local grade variability that wasn't captured by the resource model, and then there are different contacts between ore and waste, and sometimes even this geology, lithology or the alteration would shifts, and that which was not fully understood before. So in practice, we might see that systematic biases, and maybe the resource model is consistently optimistic or underestimate some parts of the domaining.
And typically, of course, one way that we can address that is by reconciliation or calibration factors, where we would look at the reconciliation of the grade control model, or even the relationship between the resource model and the grade control model, and we would apply a factor to that. Can we do better than that?
Can we do better than that? Yes, for sure. So this global adjustment, it's better than nothing, but it's very crude. And what it says is over the last year, we were 10% low in grade in this domain. So in the next year, we just multiply by 0.9 on top of what we predicted. And that's what our expectation. So, but this assumes a bias is uniform in the space across the domain or even across the whole deposit, but it doesn't really exploit all the detailed information we're collecting, especially in the multivariate settings where we probably get several metals, density, lithology, or even maybe geometallurgical variables.
Sure. Yeah. Okay, so what we're here to talk about is this idea of using machine learning and convolutional neural networks, or CNNs, which I mentioned in the introduction. So Greg, explain to us how this is going to work in this particular context.
Sure. So the key idea is that we have a small area of the deposit where we have both a large-scale resource model and the detailed grade control data. Then in the rest of the ore body, we only have the resource model. Then we can treat this overlapping area as a training data set. We could ask the machine learning model, specifically the CNN, and given that the resource model says here, and plus the geology and other variables, whether it's categorical, whether it's just numeric or alphanumeric, then what does the actual grade control data look like? So we're trying to build up the relationship between these two models, between the different various source of the input data and the ground truths defined by the grade control. And then CNN learns this relationship or the mapping, and then we can apply this learning to the rest of the area where we don't have that ground truth or the grade control data. And that is our the essence of this method.
So we have a series of data inputs, and we have some targets that we're looking to achieve. So what's the variety of the inputs? Obviously, it's just more than grades, right? We can use all sorts of inputs in this comparison between our grade control and our resource model.
Oh yes, exactly. So CNNs are especially good at handling spatial data, and they are the same type of the modeling used in image recognition. So think of the resource model as a 3D image. So each block is a pixel or a voxel, and each variables, whether univariate or multivariates, plus density, lithology, alteration, they all can contribute as different channels. So the CNN can slide 2D or 3D filters over the grid and learns the local patterns. As, for example, one lithology change from granodiorite to basalt, and the modeled grades increase or decrease. The grade control usually looks like that. And near this structure, the resource model tends to be optimistic. So we should downgrade or the downweight the estimation in this area or give it a very low confidence in that area.
Okay, Greg. So we've talked about the different types of data and relationships and categorical variables, multivariate data
Yep.
that goes into this CNN.
Yep.
What are the targets that we're trying to predict using these techniques?
Yeah, right. That depends on different contexts, but there's some examples here. So we could directly predicting grade control data, in those sparse-driven area where we don't have that grade control data yet. Or we could predicting a correlation factor or the ratio, for example, the grade control data divided by the resource model grade, or we could predicting the probabilities. For example, the probability of block is above certain cutoff or below that. Or we could predicting the dilution or loss patterns, and as observed in the grade control model, versus the resource model. So in all those cases, the CNN is trained on the overlapping area where we have both resource model and grade control model. And that's the very typical the supervised learning setup.
Right, I understand. Okay, so let's talk more about this mapping. We have this area of overlap between our dense grade control data and our less dense resource data. And how are we actually going to use the CNN in this particular case?
So we can split that into two steps. The first is learn the mapping. So for example, in the case we have couple benches of the grade control model and data, trading data, then in those couple benches, we could say use first couple as a training that and for the resource model, what we saw the grades and geology look like. And then we know the grade control model, what we actually see in the reality. And then we could feed the CNN local window, say a 3D kernel. Then with all the resource model variables, geologies as input, and then the corresponding grade control information as a target. Then over many examples, the CNN will learn that giving this combination of the information, the input information, and here is what the target looks like. Then the next step, it will move down into the lower benches that we haven't used that for the training. And we still have the resource model and geology. Then we could feed that through the CNN and it will output with a prediction. Then since we know that ground truth, then we can compare and see how this learning works. Does that work well? Does that work bad? And then we could go back and fine tune this CNN model and make it work better.
Okay.
So,
Yes, sorry.
so effectively, we're using the area with gray control as a calibration zone, and then exporting that calibration in the areas without gray control.
Right. Okay. Good. So I just point out two issues there. Here, one issue is that we're implicitly making the assumption that the geological and features of our grey control area are replicated in the sparse area that we haven't yet filled with grey control. That's one assumption we're making.
Yes.
And the other assumption is, or the other thing is, that a lot of companies or a lot of mines will add the grey control data to the resource model. In this case, we're keeping the two data sets separate, right? We're using one to forecast the other.
That's a very good point, Ian. And in the reality is, if we can separate the deposit, for example, in different zones, and then only do this type of the CNN estimation and constrain that within the same domain, that would be the most ideal situation. Whenever we cross domains, it will always be a disaster, and because we are breaking the stationarity assumptions by doing that cross domains. That's a fundamental issue. So, and then the second being, in the reality, a lot of companies combine them together. So, I guess my opinion on that is we could take this CNN as a check estimate method, where we could, because we know the ground truth, and then we could do the estimation, then we can calculate, our prediction against the reality, and then we can calculate how much error are there, and then we could use that as a quantification to assess whether this model is contributing any value or not. But by just adding up everything together, and so whatever the difference or constant bias exists between the gray control and resource model, and that will carry along in the other areas. And then essentially we are assuming that bias will exist in the rest of the ore body. So to me, I think that's also a problem.
Yeah, sure. So we're going to come back to this in the second podcast, but before we wind up, I just want to leave you with one thought, which should be obvious, is that whatever Greg's talking about here, it's not a replacement for good geology or geostatistics or interpretation. It's a supplement. So we'll come back to that in the second podcast. So for now, thank you very much, Greg.
Thank you, Ian, for having me.
And if you enjoyed that or you want to know more, please subscribe to our channel wherever good podcasts are found, and we'll be coming back to this in part 2 of the podcast.